Have you ever wondered how soil is formed? It all starts with a process called weathering. This is the very first step in the fascinating journey of soil formation. Picture the grand mountains, the gigantic boulders, the pebbles in your backyard. They all play a role in creating the soil beneath our feet, thanks to weathering. Weathering is nature's way of breaking down rocks and minerals into smaller particles. How does it do that, you ask? It uses elements like wind, water, and temperature variations as its tools. A gust of wind, a splash of rain, a freeze-thaw cycle. They all chip away at the rock, bit by bit, over time. This process is known as physical weathering. But nature doesn't stop there. It also employs chemical reactions to alter the very composition of rocks. This is called chemical weathering. For instance, when rainwater mixes with carbon dioxide in the atmosphere, it forms a weak acid that can dissolve certain types of rocks over time. These physical and chemical processes work hand in hand, gradually breaking down the rock into smaller and smaller pieces, until we are left with the fine particles that make up the soil. So, weathering sets the stage for soil formation by breaking down rocks into smaller particles. But the story doesn't end here. The journey of soil formation is a complex and fascinating one, and weathering is just the beginning. Stay tuned as we delve deeper into the world of soil in the next scenes. After weathering comes the second step, decomposition of organic matter. This process is nature's way of recycling, turning the remains of once living things into nutrient-rich soil. Imagine a fallen leaf on a forest floor. Over time, this leaf will break down, a transformation facilitated by an army of microorganisms. Bacteria, fungi, and other tiny creatures get to work, turning complex organic materials into simpler forms. They feast on the leaf, breaking it down cell by cell. As they consume, they excrete, leaving behind a rich blend of nutrients. This organic matter, the decomposed remains of plant and animal material, contributes to the formation of soil. Dead plants, animals, and microbes all participate in this cycle of life and death, decomposition and regeneration. When they die, their bodies don't just disappear. They're broken down, bit by bit, by the diligent workers of the microbial world. Microorganisms play an essential role in decomposition. They're the unsung heroes of soil formation, tirelessly working to turn death into life. They transform the organic remains into humus, a dark, fertile material that's a key component of topsoil. And it's not just about creating soil. The decomposition process also helps to recycle nutrients back into the ecosystem, ensuring that future generations of plants have the resources they need to grow. Decomposition adds life to the soil, enriching it with vital nutrients. But to complete soil formation, there's one more step. The final step in soil formation is a process called leaching. Now, don't let the term fool you. It has nothing to do with leaks. Leaching, in the context of soil formation, is a fascinating process that involves the downward movement of nutrients and minerals from the upper layers to the lower layers of the soil. Imagine a gentle rain falling on a patch of soil. As the rainwater seeps into the ground, it carries with it various nutrients and minerals. This movement, this transfer, is what we refer to as leaching. It's like a natural elevator, taking passengers from the penthouse down to the basement. However, it's not all about transportation. Leaching plays a significant role in determining the fertility of the soil. On one hand, it can be beneficial as it helps redistribute nutrients throughout the soil profile. On the other hand, excessive leaching can wash away essential nutrients, leaving the soil less fertile and less capable of supporting plant life. Now, you might be wondering, does leaching occur at the same rate everywhere? The answer is a resounding no. Different soil types can greatly affect the rate of leaching. For instance, sandy soils, with their large particles and loose structure, allow water to pass through quickly. This means they are more prone to leaching. In contrast, clay soils with their small particles and compact structure slow down water movement, reducing the rate of leaching. So, the next time you see a raindrop hitting the ground, remember that it's not just a drop of water. It's a vehicle, a transporter, carrying essential nutrients on a journey through the soil. It's a vital player in the story of soil formation, contributing to the continual transformation of the earth beneath our feet. And there you have it, the journey of soil formation from weathering to decomposition, and finally leaching. Remember, every handful of soil is a story of transformation.